these skirts, aka particles, are more over here than they're less over here. And we have a membrane. I think we need to cross some particles across the membrane to where there are less particles.
I do too. So let's take some of these particles across the membrane and bring them over to join with these particles.
And what process are we using to do that?
Diffusion.
Diffusion is the crossing of particles across the membrane. Gosh, I'm thirsty and this water fountain is sure tempting me.
Wow, I can see it has a lot of water molecules in you. Maybe it can help you with the process of osmosis.
Yeah, but I might have some trouble getting my membrane up to the water fountain.
Yeah, I could see how that would be hard. The water molecules have to go through the cell membrane, not the proteins.
Yeah, maybe we should just go get a water bottle because the osmosis, it does have to go through my membrane, so I have to drink sometime. Yay, osmosis. Now I'm not thirsty. Osmosis is the crossing of water through the membrane of the cell.
Hey Fiona, don't you think we're making so many connections today?
Totes. Like this is a membrane and we're crossing it using energy. What process is that?
Active transport.
Unlike passive transport where we wouldn't use energy, right?
Right.
Active transport is movement of particles across the membrane with the use of energy.
Oh my gosh, this is just like active transport, but it's passive transport, which doesn't take energy.
Yeah, we aren't using energy because we're going on the escalator and we're still moving across membranes. Passive transport is the movement of particles across the membrane without the use of energy.
I'm going to pretend to use endocytosis to buy this charm. The charm, my hand is the vesicle, the charm is the particle, and I will take the vesicle, surround the charm, and bring it into the cell.
And I'm going to use exocytosis to return this charm. My hand will be the vesicle again, and this will be the particle. But I already have the particle in me, the cell, and I will put out the vesicle and return my charm. Endocytosis is when the vesicle surrounds a particle and brings it into the cell. Exocytosis is when a vesicle surrounds a particle and brings it out of the cell.
Photosynthesis!
That's an easy way to make energy and food. Since I'm a plant, I can use water, carbon dioxide, and sunlight to make my food, which makes my energy. It also makes oxygen.
Photosynthesis also makes oxygen, which helps animals and humans live. Photosynthesis, the process in which plants and some bacteria use water, carbon dioxide, and sunlight to make food.
Gee, I'm hungry. Let's go to the food court.
Okay, it sure looks like the food will help the mitochondria in us use cellular respiration to release energy into our food.
We could also use fermentation to get energy from our food.
True. For example, the yeast, it forms carbon dioxide, and the bubbles of CO2 gas causes it to rise, giving us fermentation.
Thanks cellular respiration and fermentation, now we can get energy from our food.
Fermentation, the breakdown of food without the use of oxygen.
Cellular respiration, the process by which cells use oxygen to produce energy.
I was reading an article about mitosis yesterday.
Did you know that before mitosis begins, there's a step called interphase, and that's when the chromosomes double and become chromatids?
Then the chromosomes condense and the cellular membrane dissolves is the second step of mitosis, prophase.
OMG, yeah, then in the third, metaphase, the sister chromatids line up in the middle of the cell.
Then microtubules pull the two sister chromatids to opposite sides of the cell.
And in telophase, the nuclear membrane reforms and the chromosomes become skinny again.
Lastly, cytokinesis, when the cytoplasm splits to form two daughter cells.
Now we're going to get our tosis done.